Alright, hey C-Block, this is the last video for now. This is on MFM1, which says I can calculate or use the momentum of an object. So we've got two equations that we're going to want to be using for this problem. We're going to be wanting to find out what the change in momentum is, or delta P. And we know that we're going to want to be able to figure that out because we see that we have, well, let me read the problem to you. It says, calculate the final velocity of a 1.5 kilogram iguana that has an initial momentum of negative 15 kilogram meters per second and experiences a change in momentum of plus 25 kilogram meters per second because it is falling onto a trampoline. That is one of iguana's favorite things to do, we've found out. We want to find the final velocity of the iguana after it experiences that kind of change. So this is going to require two different equations for us to use. One is we're going to need to use that initial velocity and the momentum change that we're given to find the final momentum. And then we're going to take that final momentum and we're going to use it and the mass that we're given of 1.5 kilograms to find the velocity. And we're going to have to, of course, rearrange this equation to solve for velocity using our pyramid, or algebra, of course. So let's start with that. P, M, V. So let's check to see if we're right. I know that P equals mv because that's the equation I'm starting from. I cover up the P and I see that it equals m times v, so that checks out. I've done it correctly. Whenever you're looking for the change in something, it's always the final value minus the initial value. For instance, in Tucson, a typical day might see our final temperature being 100 degrees Fahrenheit, and when we wake up in the morning it might be 70 degrees Fahrenheit. So 100 minus 70 is 30, and that means we have a change in temperature of 30 degrees Fahrenheit. And notice that that's positive because it went up. So this works. This makes sense. All right, so let's get started then. So we're given that the mass is 1.5 kg. We've got an initial momentum of negative 15 kg meters per second, and we have a change in momentum of plus 25 kilogram meters per second. So since we want the final, we're going to actually have to use just a tiny little bit of algebra here. We're going to add pi to both sides so that we can solve for pf. And we find then that we have pi plus delta p equals pf. Now we can diagram the equation the way I like to do. And our initial is negative 15. And then plus the delta p, which is 25, plus 25. Negative 15 plus 25 is the same thing as 25 minus 15. And that's going to equal 10. All right. And so now that is our PF. So that's going to be, since it's momentum, it's kilogram times meters per second. And now we're looking for the velocity. That's what we want, velocity final. And this is where we're going to get it from. We cover up velocity here and we get P divided by M equals velocity. And so P is 10. Mass is 1.5, and 10 divided by 1.5 equals 6.6 repeating. So I personally usually would write 6.7. And again, this is velocity, so what is velocity? What are the units? Take a second to think about that. And hopefully you said that they were meters per second. That's how you do the mastery level MFM1 from the quiz that we had on 4/11/19.